All right, we're going to go through a few problems here for the first part to this quiz key. And the first one is a direct and inverse variation question where we have a fixed voltage K and a current, which is I, that varies inversely as the resistance R. So I varies inversely as R, which means we would have I equal to K divided by R. And we do not know what that constant voltage K is. So then we know that the current is 8 amps when the resistance is 15 ohms. So that means we know that 8 is equal to the unknown constant divided by 15 ohms. And if we solve that, we would determine that our K is going to be 120. So there we've solved for our constant K, which means we can go ahead and record like a formula with this constant voltage as 120 instead of a K. And so now the current is going to be equivalent to 120 divided by the resistance. And then finally it asks what will be the resistance when the current is 5 amps. So if the current is 5 amps, that is going to go in for your I. So that would be 5 equal to 120 divided by what amount of resistance. And if you would solve that you could use your cross products to solve, you would have 5R equals 120 when the resistance is 24 ohms. Okay, so that is a little direct and inverse variation question there. For these next two problems, we have to multiply or divide, and before we go ahead and do that, we want to factor each numerator and denominator to see if there are any common factors which we could then pull out as a factor of 1, because like if I have an x plus 3 over another x plus 3 factor, that is equivalent to 1. So I can get rid of those. And I also have a common factor I see here, 3x plus 1 and 3x plus 1 there. So when I'm all said and done and have factored out all my common factors, what I'm left with here is 3x minus 1 all over x minus 3. That would be the simplified product of those two rational expressions. And then we have to account for our restrictions in the domain. So x cannot equal anything that makes a denominator 0. So negative 3 would be a no-go there. 3 would not work there, nor would negative 1/3. So those values, plus or minus 3 and negative 1/3, are not going to work out there for number 2. Okay, number 3, since we are dividing, I'm going to change that to multiplying by the reciprocal. And so you'll notice that this second expression right here, the one that I was dividing by, I had now taken the reciprocal of that. So instead of the green over the purple, I now have the purple over the green. And everything is factored. So now I can go ahead and look for my common factors to reduce. And here I see a 3 and a 3. And remember, factors are multiplied, so those are multiplied together. And so they're able to reduce. I have an x over an x, which really is just a 1. Looks like I have an x plus 7 and an x plus 7, and I have an x minus 7 and an x minus 7, and holy cow, everything reduces. So remember, when this happens, what's left if everything's gone is there's a factor of 1 that's always there. There's a factor of 1 that's always there here. So really this is 1 over 1. So all that is just another way of writing 1, so long as we don't have any zeros in our denominator. And so that x cannot equal anything that would make a denominator 0. In that case, that would be 0 itself here, or plus or minus 7. So the restrictions on the domain, or the x, cannot equal 0 or plus or minus 7. In these next two, we're going to have to add or subtract. And remember, in order to do that, we need common denominators. So what's going to happen here is I'm going to factor my denominators so I can tell what I need to have in common. And so this first expression is x over x plus 2, x minus 2, because they're a difference of squares. And that's going to be added to 1 over x minus 2. So you can see here that in this problem, I have two different factors, x plus 2 and x minus 2. And over here, I do have in common an x minus 2. So if I want to get those denominators to match, then I need the red factor of x plus 2 on the right. So I'm going to go ahead and multiply that one by x plus 2 over itself, which is totally legal because it's just like multiplying by 1. So then I'm going to go ahead and simplify those up a bit. And once I have common denominators, then I can go ahead and combine these two together. Okay, so now the denominators match, so I can go ahead and take the numerators, and I'm going to add x to x plus 2. And a common mistake I'll see here every once in a while is that when someone adds x plus x, they'll write it as x squared. And that would actually be multiplying. So x plus x, it helps if you put a number in front of there. 1x plus 1x is 2x plus 2 all over x plus 2 times x minus 2. And then it looks like I can factor the numerator a little bit. So if I were to take that 2x plus 2 and factor out a 2, I would actually be left with 2 times x plus 1. But that doesn't allow me to factor anything, so it's not really going to get us anywhere. So there's our final sum in simplest terms. And it says identify the values for where it's undefined. So x cannot equal plus or minus 2 because that would make our denominator 0. Number 5, we are asked to subtract these two expressions, and they do have like denominators right off the bat, so we don't have to do anything special there. We just have to go ahead and subtract the numerators and write them over one denominator, 4x minus 2. And if I can factor anything, I should do that just to make sure nothing reduces. So I can factor the denominator. I can take a 2 out. And when I do that, lo and behold, I have the ability to get rid of these factors 2x minus 1. So really this is equivalent to 1/2. And the restrictions is that x cannot equal positive 1/2. So that concludes questions 1 through 5. And tune into the next video if you want to see the next questions, which would be 6 through 8. Thanks.